What is the average of the smallest angles of all triangles by Martin Tutorials? I recently made a YouTube called A Great Fun Triangle Experiment. This one appeared on both my YouTubes. I showed a fun experiment with paper, and among the people who saw it in the comments section was a viewer with username Let Me Say That in Irish, or Let Me Say That in Irish. And he had a great question. I'll quickly read it. I have a question about triangles. What is the average of the smallest angles of all triangles? That is, take the set of all triangles, sample a huge number of them. For each triangle, find the smallest angle, sum these smallest angles up, and divide by the sample size. What would you get? We had a little conversation about it in the comments section, and he's absolutely correct. Average is about dividing by the sample size, taking all the total and then dividing by the number of triangles. And as a reminder, I have two YouTubes, Variety and Fun Math and Martin Tutorials. Variety and Fun Math is unrelated to math and math for most people. Martin Tutorials is for all mathematics. As today's question is more advanced, arguably, it's only going to Martin Tutorials. As usual, my two YouTubes are free to subscribe and come with a full refund policy. And on to today's question. Okay, this question is about average. And just a reminder, average is the weighted middle. Like, let's say I have three boxes. This one has 2 balls, 1 ball, and 9 balls. The average is all the balls, or in this case dots, divided by the number of containers. So the average is 2 plus 1 plus 9 divided by 3, which is 12 over 3, which equals 4. And here we've got 3 boxes with 4 dots and 2 boxes with 9 dots. I could say 4 plus 4 plus 4 plus 9 plus 9 divided by 5. Or what means the same thing is 3 times 4 plus 2 times 9 divided by 5. And we get the same answer, which is 30 over 5. The average is 6 dots per box. Okay, that's an introduction to average. It's the weighted average. Now we're going to do the same thing with triangles. And of course, with triangles, for finding the average, we could make it continuous where any angle is possible. You could have 4 1/4 or 5.77, just infinitely many angles. I'm going to do it where it's only integers. So one example is an angle of 178. Of course, every triangle, it has to add up to 180, or 1, 2, and 177 also adds up to 180. So one way to find the average is to take every single triangle, line it up, every triangle possible where the angles add up to 180 and all the angles are integers. And with each one, we find the smallest angle and we add up all those smallest angles, and then we add up all those triangles and divide all those angles, their degrees, together and divide by the number of triangles. And that is the method to go. Okay, and another way to do it, I line up all those where the smallest angle is 1. I line up all of those where the smallest angle is 2, all the way up, believe it or not, to the one where the smallest angle is 60. You'll see if the smallest angle is bigger than 60, that triangle will not be possible. All right, and it's a similar concept to here. Remember I said like 3 times 4? So for all those where the smallest angle is 1, if I count them, it's that number times 1. And I don't know what it is, so I put a question mark. I am going to work it out. Plus the number, there are 2, etc., all the way up to 60. So where I wrote the number of containers with that number of dots, that's where I put a question mark. There it was dots. Here it's the number of containers, and that refers to the amount of dots. So I'm just making up a number. Let's say I counted 15 where the smallest is 60. that would be 15 times 60, but I don't know what the answer is. And that divided by the total number of triangles. The number of those with the smallest is 1, plus the number with the smallest is 2, all the way up to the ones where the smallest is 60. So that's what I'm going to now calculate. Okay, I made this chart. Let's start off with all the triangles where the smallest angle is 1 degree. If the smallest is 1 degree, another possibility is 1, and the other two angles is 1 and 178, because they have to add to 180. The next possibility is 2 and 177, because they have to add to 180, until we get to a 1 ... because I'm not going to go through each one. Eventually we get to 89 and 90. If I went one up, I went 90 and 89, that's repetition, that's the same triangle. So if we add this all up, 1, 2, 3, 4, 5, 6, 7, ... up to 89, there are 89 triangles. There are 89 triangles possible where the smallest angle is 1. Now if we do another triangle where the smallest angle is 2, we've got, now the next one cannot be 1 because 2 will not be the smallest. So it will be 2 and 176, the other two angles. 3 and 175, that's the other two angles in a triangle. And then we list all those triangles all the way until we get to 89 and 89. So a triangle with 180 is 2, 89, 89. And if this goes up to 90, that would be 88. That 90 would no longer be the smallest angle. And we actually did have 88 and 90. We just didn't write it in to save time. And I carry on with angle 3, angle 4. And I could go through each one, where I go through each possibility of the triangles. So let's say if the smallest angle is 7, the next angle starts off at 7, and then the third one would be 166 to add up to 180, then 8 and 165, and all the way until 86. So we can have a triangle with 7, 86 and 87. So I've listed all the triangles where the smallest angle is 7. Well, I didn't list them because I left it out, but I'm implied that they're there. And if I add up how many triangles, the biggest, if the smallest angle is 7, then the biggest next angle, that's the second smallest, is 86. But if I see that starts at 7, we left, that means we don't have 1, 2, 3, 4, 5, 6. The number of triangles is 86 minus 6, which is 80. And if I just do one more, if the smallest angle is 8, that second smallest would be 8, 9, 10, 11, 12, 13, 14, all the way up till 86. And that would be the corresponding third angle. So if it's 8 and 8, we need 164 to add up to 180. If it's 8 and 86, the third one would be 86 to give us that 180. And if we add it up, this goes from 8 until 86. We do not have a 1 to 7, so we subtract 7. There's 79 such triangles. So here's examples of the smallest angle and the possibilities. I didn't write them all in, and how many of those triangles. And we carry on like this, 57, 58, 59. If it's 60, then the next smallest is 60, and then the third one can only be 60. That's, if the smallest is 60, it's a triangle with 60, 60, 60, okay? So here's my chart. I didn't do all the 180 possibilities. I restarted at 57. And in this column is the number of triangles possible. And I've noticed a pattern: 89, 88, 86, 85, 83, 82. This drops by 1, drops by 2, drops by 1, drops by 2. 83 minus 1 is 82. 82 minus 2 is 80. So if I had to write out all the triangles where the smallest angle is 7, there's 80 such triangles. To do the arithmetic, what I'm going to do now, because for the number of triangles, I should theoretically add up all these totals for the how many of each, as well as for the, the total number of angles is 89 times 1 and 88 times 2 to add up the angles. Now, to make it easier arithmetically, I divide it into two. I'm taking those where the smallest angle is odd numbers and those where the smallest are even numbers, and then adding it together because the arithmetic will be easier. If I take those where the smallest number is odd, we've got 89, 86, 83. We're subtracting 3 each time. If we do those where the smallest number is even, we've got 88, 85, 82. They go down by 3. It's the same amount. The arithmetic will be easier. Okay, so now I'm going to start off where the smallest angle is 1. And then the next smallest angle is 3. And I'm going to call it set A. And the total number of angles would be 89 times 1 plus 86 times 3 plus 83 times 5. That's adding up all the angles of this, well, those with the smallest and odd number. 89 times 1, 86 times 3 times 83 times 5, all the way until 59 times 2. If you took all the triangles where the smallest angle is 59, there are two possibilities. 59 and 62 and 60 and 61 are the other two angles. And as there's not many, I can actually write them all. I don't have to put like dots in between. Okay, so there I've lined up. I've called this set A. The one where the smallest is even I call set B. So what I need to do now is add up 89 times 1 plus 86 times 3 plus 83 times 5, all the way down to 2 times 59. As you can see, the left number is going down by 3. The right number being multiplied is going up by 2. So one method is to actually physically count each one. It's a lot of counting, or maybe a computer or calculator can do it. Another way is to treat this as sigma notation. If anyone's ever seen this notation before, if I have an equation and the sigma notation says from n equals 1 to n equals 30, it means keep rewriting this equation over and over again, where n equals 1 and then when n equals 2 and when n equals 3, I keep adding it all up until I reach 30. Because if n equals 1, 92 minus 3 is 89, 2n minus 1 is 1. If I plug in n equals 2, I'll get 86 times 3. If I plug in n equals 3, you will see I'll get 83 over there, and I'll get a 5 there. And all the way when n equals 30, I will get 2 times 59. So it means keep on. This is a quick way of saying, write this equation out 30 times, plug in a 1, plug in a 2, plug in a 3, plug in a 4, all the way until 30, and then add them all together. And to make it simple, I keep the sigma notation, I multiply out all the terms, and I get minus 6n squared from minus 3n times 2n, and minus 1 times minus 3n is plus 3n. So this is multiplied out. I collect the like terms, that's 184n plus 3n is 187n. So we've got sigma notation of this equation. So these two equations are the exact same thing, just this one's easier to work with. And then with sigma notation, I can break it up. Instead of saying, repeating all of this over and over again, 1 to 30, I could do this one from 1 to 30, plus the second term 1 to 30, plus the third term 1 to 30. So there it is. There's minus 6n squared from 1 to 30. And instead of saying from 1 to 30, 187, I can take out 187 as a common factor, because this is 187 times 1 plus 187 times 2 plus 187 times 3 all the way until 30. If I take out 187, it's 1 plus 2 plus 3 plus 4 all the way until 30 times 187. And if I wrote this equation out 30 times, plugging 1, 2, 3, 4, 5, etc., that will remain minus 92 all the way. So it'll be minus 92 and minus 92 and minus 92 30 times. So it's 30 times minus 92. And here I can take out minus 6 as a factor. I did something, it's not a mistake, it's a little bit inconsistent. Here I took out 187 over here. Here I took out minus 6 the next step. It's more logical to do them both at the same time. Either take them both out as a common factor now, or take them both out a step later. It just sounds logical to do it at the same time. Like this is a step when I'm taking it out. But anyway, I happen to take out this minus 6 over here. And I happen to forget to write in the 187 over here. So I'm writing it in. There should be a 187 written in here. Okay, so I've got minus 6 times sigma notation n squared from 1 to 30. That's n squared sigma notation 1 to 30 is 1 squared plus 2 squared plus 3 squared all the way up to 30 squared. This is 1 plus 2 plus 3 plus 4. And 30 times minus 192 is minus 2760. Okay, the formula for n squared is from 1 to w is w times w plus 1 times 2w plus 1. In this case, the w is 30. It's n squared from 1 to 30 would be 30 times 31. 2 times 30 plus 1 is 61 divided by 6. And if we do the arithmetic, that's 9455. That's all the n squareds put together. So this is really minus 6 times 9455. The value for all the n's added up, 1 squared plus 2 squared plus 3 squared up to w is w times w plus 1 divided by 2. So if it's until 30, it's 30 times 31 divided by 2 equals 465. So if we had 187 times 465, I wrote it in over here, and this is minus 2760. So we've got these numbers added up. Minus 6 times 9455 plus 187 times 465 minus 2760. Plug in the calculator, we get 27,465. And this is all for set A, those where the first angle is the smallest angle is an odd number. Now we've got to do those where the smallest angle is an even number. Okay, so there's 88 triangles where the smallest angle is 2. There's 85 angles where the smallest angle is 4, etc. Which I wrote over here, 82 times 2 times 85 times 4, all the way until 1 times 60. There's only one triangle possible where the smallest angle is 60. And now everything's exactly the same. This is the formula. I'll do the easy part first. We multiply by 2n. This is all the values of n from 1 to 30. That's 2 times 1, 2 times 2, 2 times 3, all the way until 2 times 30. And to achieve this number, I've got 88 minus 3 times n minus 1. If we plug in n equals 1, n equals 2, n equals 3, we'll get 88, 85. So for example, I'll just take the third term when n equals 3. We plug in a 3, 3 minus 1 is 2, minus 3 times 2 is minus 6, 88 minus 6 is 82. And if n equals 3, 2 times 3 is 6. So we plug n equals 3 into this equation, we get 82 times 6. If we plug in n equals 2 into this equation, we'll get 85 times 4. So that's the equation. And once again, we want to simplify it. So with minus 3n plus 3, that's multiplying out this bracket. And 88 plus 3 is 91. 91 minus 10 times 2n. And we can multiply the 2n in. We get 182n. That's 2n times 91 times minus 3n is minus 6n squared. So we've got this equation from n equals 1 to 30 of 182n minus 6n squared. And I'll go a little bit fast because it's the same process before. We take out 182. It's the same equation before for 1 plus 2 plus 3. It's n times n plus 1 divided by 2, or 30 times 31 divided by 2, which is 465. And all the values from 1 to 30 of n squared we calculated before is going to be where is it? 9455 times minus 6, and 182 times 465 is 84630, minus 6 times 9455 is 56730. We get 27,900. Okay, so that's the total number of angles in set A, total number of angles in set B. So that's the total number of angles, is these two numbers added. Okay, now we want to know the, and I can even show, here's my angle. Here's the total angles. My two numbers, 27465 plus 27900. That's the two numbers I got. Now we want to know the number of triangles. The average is all the angles divided by the number of triangles. Well, there we've got 89 triangles with 1, 88 triangles with the smallest is 2, 86 triangles with the smallest angle is 3. So we've got to add up 89 plus 88 plus 86 plus 85, etc., which I wrote here. And once again, it's easy to separate it into set A and set B. I take every second one, add them together, 89 plus 86 plus 83, I rewrote here. And here, 88 plus 85 and 82. So I separated, like term 1, 3, 5, 7, I put on the left. Terms 2, 4, 6, 8, I put on the right, because it's easier, because they go down by 3. I worked out mathematically how many terms, but we already know it's 30 terms in each one. And this is the formula. It's called an arithmetic progression. I can look at it from right to left or left to right. If they're all going up by the same amount, this is the formula to add up all the terms. It's the first term plus the last term times the number of terms divided by 2. So it's 2 plus 87, 2 plus 89 times 30 divided by 2 is 1365. And that's the total in set A. And set B, same thing, 30 terms divided by 2 times 1 plus 88. And the arithmetic comes to 1335. Okay, so total number of triangles is 1365 plus 1335. So the average is the total, find the average. If we lined up every single triangle possible, okay, if we add up all the smallest angles, we're going to get 27465 plus 27900. That's the two totals we got over here. And if we want the total number of triangles, it's these two numbers, 1365 plus 1335. And if I add the two numbers on top, we get 55,365. The two numbers at the bottom is 2,700. And that's like, if we punch in a calculator, it's 20.5055555 going on forever, which is to 2 decimal points is 20.51. Or as a fraction is 20 and 91 over 180. That means if I lined up every single triangle possible with integer angles, and what is the average smallest angle, it would be 20.51. That's to the nearest 2 digits. And any questions, anything you don't understand, let me know. I should have made that 8 more clearer, because I used a marker. Hopefully that's neater. You see, I've only got one hand available because the other's holding the pencil. And here's a panoramic view. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I used 10 pieces of paper to answer this question, and I had to line them up methodically on the table. And when I went close, I went from one paper to the other. But anyway, I hope you enjoyed this question. It's the longest one I've done. I enjoyed producing it. And despite my handwriting, I hope you all understood. Any questions, let me know. And have a great day to everyone. And talk to you all soon.